Hello everyone, welcome to Learn Ladder Logic. I'm Rashiranka and we are going to start with Chapter 1, Grade 10, NCERT textbook, Real Numbers. So let us understand the two types of numbers, prime numbers and composite number. Prime numbers are those numbers which don't have any factors except 1 and the number itself, whereas composite numbers are the numbers which are just opposite to the prime numbers. So let us understand the prime number in an easier way, like those numbers which don't come in any other tables, which comes only in their own table and one's table. Ignoring the one's table because all the numbers come in one's table, let us understand few examples of prime numbers and composite numbers which would make you understand this topic very well. For example, let's start with number 2. 2 is a prime number. It is the only even prime number. So, 2 is a prime number because it comes only in two tables. 3 is again a prime number. Whereas 4 is a composite number because it comes in two tables and four tables. 5 is a prime number. 6 is a composite number because it comes in two tables as well as in three tables. Number 7 is a prime number. Now I would just ignore all the even numbers because all the even numbers are composite numbers except the digit 2, the number 2. Now 9 is a composite number because 9 comes in three tables and the 9 tables. 11 is a prime number. 13 is a prime number. 15 is a composite number because it comes in three tables, five tables and 15 tables. 17 is a prime number. 19 is a prime number, and the list goes on. And the composite number list also keeps on going. There are infinite numbers of prime numbers and composite numbers. Now, let us understand the topic which we are learning, real numbers. What are real numbers? Real numbers are combinations of rational numbers and irrational numbers. Here, I can explain this well that rational numbers are those numbers which are written in P by Q form. P by Q form is a fraction form where P and Q are integers. So here integers are those numbers which are negative and positive, right? And this Q here, the denominator should not be equal to 0. Okay? So I can just write an example. A number normal just like 5. 5 is a rational number. We can just write it as 5 by 1, right? We can write minus 3 by 2. These all are rational numbers because these numbers are written in P by Q form. Okay? Irrational numbers are the numbers which are other than the rational numbers, or maybe not rational numbers are the irrational numbers. For example, root 2, root 3. These are irrational numbers. Okay? Now let us go to the topic, to the chapter which we are learning, the real numbers. Chapter 1. This chapter is divided into two subtopics, the Fundamental Theorem of Arithmetic and Irrational Numbers. Okay, so now let us understand what is the fundamental theorem of arithmetic. The fundamental theorem of arithmetic states that every composite number, that is, every composite number is expressed in the form of the products of prime number. Okay. Now we have understood what a composite number is and what are the prime numbers. Right? So now it is easy for us to understand this concept and do the prime factorization of the numbers. Let us take two numbers, number 24 and number 4095. Okay, so let us do the prime factorization of these numbers. Let's take the smallest number first. The prime factorization of 24. 24. Prime number, the smallest prime number is 2, which is the 24 is divisible by number 2 because the unit place, the last digit is an even number. So we'll just write 2, 12. Again, the unit place is an even number. So it is divisible by 2. 6, 2, 3, 3, 1. Okay? So I can just write this 24 is equal to 2 to the power 3 into 3. Correct? Right? Here I wrote 2 to the power 3 because you can see the number 2 coming thrice. So 2 to the power 3 into 3. Now let us do the prime factorization of next number 4095. Here you see the unit place is not an even number. So it is not divisible by number 2. Let us try with the number 3. The divisibility test of number 3 is adding the digits of the number. So adding 4 plus 9, 13, 13 plus 5, 18. 18 comes in 3 table. So this number is divisible by 3. So let's take 3. 3, 4, 1, 1, 0, 9, 3, 1, 9, 6, 1, 5, 5. Okay. Again, let's check whether it is divisible by 3 or not. 1 plus 3, 4. 4 plus 6, 10. 10 plus 5, 15. Yes, it is divisible by number 3. So just solving it again. 3, 4, then 1, 6, 5, 1, 5, 5. Now let's do the divisibility test by 3 again and check whether 455 is divisible by 3 or not. 4 plus 5, 9. 9 plus 5, 14. No, this number is not divisible by 3. So let's go to the next number, number 4. Number 4 can't be used here because the number is not an even number. Okay? Number 5. Number 5, yes, the number is divisible by number 5 because the unit place is 5. So let's divide it. 591. Now I'll continue this here. Prime factorization of 91. 91 is 13 into 7. So this number can be written as 7, 13. 13 is a prime number, 13, 1. So we can write 4095 is equal to 3 to the power 2 into 5 into 7 into 13. Where 3 to the power I have written 2 because the number 3 is coming twice. Number 5 is coming once, so 5 to the power 1, 7 to the power 1 and 13 to the power 1. Okay, I hope you understood it and it is easy for you guys. Now we move to the next topic, the concept of LCM and HCF. We have learned this topic in our lower grades. Let us just recall it and understand it in much better way so that you don't forget it during your exams. LCM is the lowest common factor, multiple, whereas HCF is the highest common factor. Let's do the prime factorizations of number 96 and 404. I would like you all to do the prime factorization without seeing the video and comment down the answer. 96, 2 table because unit number is even number, 248, again 224, again 212, again 26, again 23, 3 and 1. Okay, so I'll just write 96 here. 96 is equal to 2 to the power 5 because you see the number 2 coming 5 times into 3. Let's do the prime factorization of 404. Number 2, because the unit place number is an even number, so it will be 202. I'll just do it once again. Then again number 2, 101. Here 101 is a prime number, so we are leaving the number the same way. 101, 1. So I can write 404 is equal to 2 to the power 2 into 101. I'm just erasing the sign of prime factorization. Now, let us understand the LCM and HCF of these numbers. LCM. LCM is simple. Least common multiples. Multiples are, you just remember, it is given least, but the answer is always more than the HCF. So I can just write, it is just opposite. The number is the highest number. It is the multiples. Now, to understand this, how to write the answer, LCM is very easy. You just write the varieties of number available to you. Now, here, you can see the variety of number 2 being available in the question, 3 being available in the question, and 101 being available to you. So, I'm just writing the possible numbers available to me. 2 into 3 into 101, right? Now, what I'll do, I'll see the highest power that number has in the question. Here you can see in 96, it is 2 to the power 5, right? And in 404, it is 2 to the power 2. Which is the highest degree or which is the highest power? Number 5 is the highest. So I'm just writing 2 to the power 5. Similarly, I'll check for number 1, 3 and number 101. Here, the highest power the number 3 have is 1 and the number 101 has is also 1. So I'll just multiply the answer. I'll just multiply all these numbers and find the answer. So here I'm just writing 2 to the power 5 is 32 and 3 into 301 is 303. Simple. Now we'll just multiply these numbers and see the answer. Okay, so 303 into 32. 6 0 6 0 3 9 0 9 and adding all these things, all these number 9696. So I'm just writing 9696. 9696 is our LCM. Now let us find the HCF. HCF is equal to the common number available. Only the common numbers available. So here the common number is 2. You can only see the number 2 being available. And now you should write the lowest power available of that common number. What is the lowest power of 2 in the question? Comparing 5 and 2, it is 2. The lowest power available is 2 square. The answer is 4. I hope you understood the difference the LCM and HCF has. These both are very opposite to each. Like you see the least common multiple and you see the highest common factor where the least thing but the answer is the highest. And where the highest thing, the answer is the least, lowest one. Okay, so now, and you can see in the power also, LCM in the power, in LCM the power is the highest power, whereas in HCF the power is the lowest one. I hope you understood this. And there is one beautiful thing in this thing, the LCM and HCF concept. One thing to remember as per your exam point of view, that the number LCM into HCF is equal to the number itself. For the example, A into B are your numbers. So the LCM of A comma B and the HCF of A comma B is equal to the product of the number itself. The product of LCM and the product of HCF is equal to the product of those two numbers. Let us try in this question. We have the LCM of 96 and 404 as 9696 into the HCF as 4. Let us check whether it is equal to 96 into 404. Okay, I'll try it here. 9696 into 4. 4 nines are 24. 4 4 6 are 24. 4 nines are 32. 36. Sorry, yeah, I'm just getting confused. Yeah. 4 9 6 are 24. 4 nines are 36, 37, 38. 4 6 are 24, 25, 26, 27. 4 6 nines are 36, 37, 38. So here I got the answer as 38784. Okay, 38784. 8, 4. Let's check whether it is equal to 96 into 4 not 4. I'm just taking 4 not 4 into 96. 6 fours are 24, 2, 4, 6 0 0, 2, 6 fours are 24, 0, 9 fours are 36, 6, 3, 9 0 and 9 0 plus 3, 9 fours are 36. I'm adding the number digits. 4 plus 0, 4, 2 plus 6, 8, 4 plus 3, 7, 2 plus 6, 8, and 3. You see the numbers are equal, right? So just remember this rule that LCM of A comma B into HCF of A comma B is equal to the product of those two numbers, that is A into B. Understood? Now let us go to the next concept and try the LCM and HCF of 3-digit numbers. Okay? 6 can be written as 2 into 3. So we know this. I'm just writing the answer directly. Okay? 72. Let's find the prime factorization of 72. 72. 2. Because the digit number is an even number. 36. Again 2. 18. Again 2. Then 9. 3. And 3. And 3, 1. So 72 can be written as 2 to the power 3 into 3 to the power 2. Simple. Now let me do of number 120. 120 LCM 2, 60, 2, 30, 2, 15. 15 comes in 3 tables because when we add the digits, 1 plus 5 is 6. 6 is divisible by 3. So 15 is also divisible by number 3. 3, 5, 5 and 1. Okay, so I can write 120 is equal to 2 to the power 3 into 3 into 5. Simple. Now, let us do the LCM and HCF of these numbers. LCM is equal to what I told you related to LCM. Write the all possible numbers given to you. All varieties of numbers. The variety of number we have is 2, 3, and 5. Now write the highest power given to these numbers. In 2, you can see the highest power is 3. So I'm just writing 3. The highest power available for 3 is 2. So I'm writing 2. And the highest power available for 5 is 1. So let's multiply. 2 to the power 3 is 8 into 9 into 5. And what is 8 into 9? 72. 72 into 5 is 5 2s are 10. 35, 36. So the LCM is 360. Whereas let's find the HCF. HCF is the only common numbers you have available, and here there are 3 numbers. So the common numbers available in all these 3 digits. What are the common number available? 2 and 3. Correct? Now let's check what is the lowest power available to these numbers. Here you can see the lowest power available in 2 is 1 and the lowest power available in 3 is also 1. So we are going to just write those numbers 1, 1. Done? Fine. 2 into 3, 6. Okay. Here it should be mentioned to that in 3 digits number, 3 numbers, sorry. If you have 3 numbers available to you, the rule of HCF A, B, C into LCM A, B, C not equal to A into B into C. Okay, I hope you understood this, that this rule is only available or only applicable. Which rule? HCF of A, B into LCM of A, B is equal to A into B. This rule is only applicable for 2 digits number. 2 numbers only. The 2 numbers only this rule is applicable. Okay? I hope you understood. Now let's move to the next topic of this chapter, the irrational numbers. Here, in irrational numbers, you have one theorem 2, 1.2 theorem, where it says, let P be a prime number, where if a P divides A square, then the P would also divide A. Okay, so let's write that here in the question example given to you. 2B is equal to root 2. Fine. I'll just square the sides, both the sides. So it would be 2 4B square is equal to 2. 2. Okay. Here I can tell that number 4 here. 4 divides 2 and 4 also divides root 2. 4 divides 2 and 4 also divides root 2 because of the theorem given to us. I hope you understood this. Fine. Let's move to the next topic. The topic which is just you have to mug up. You have to prove that root 2 is an irrational number. How will you prove that thing, that root 2 is an irrational number? This can be done by proving that, firstly prove that root 2 is a rational number, then we'll show that this assumption is wrong and hence prove it as root 2 is an irrational number. So let's see how would you write a question if you are given for this type in the examination. Here, just see the format, how I'm writing everything, and understand the same exact way you have to write it in your examination. Let's prove that root 2 is an irrational number. Here, what we'll do, we'll write, let us assume that to the contrary, that root 2 is a rational number. Fine. Here, when a number is a rational number, I told you we can write it in P by Q form. So I'm just writing it. Root 2 is equal to root 2 is equal to A by B, and to mention where B is not equal to 0 and A comma B are co-prime numbers. Okay. Co-prime numbers are those numbers which have only one as their common factor. Means both the numbers are co-prime numbers and they have only one as their common. They cannot be simplified in a smaller number. For example, if I say 8 by 16, here 8 by 16 is not a co-prime number because these two numbers can be simplified in a smaller way. Instead, we can divide both the numbers by 8 and write it as 1 by 2. Here 1 by 2 is a co-prime number because there is only the number 1 as a common factor. Okay? I hope you understood what co-prime numbers are. Now, root 2 is equal to A by B. Here I'll take this B this side and multiply, which I can write it as root 2B is equal to A. Now I'll square both the sides. Okay? So squaring both the sides and I'll write squaring both the sides. Okay? When I square both sides, it can be written as 2b is equal to b square is equal to a square, right? Now, the theorem which we have learned above, we can tell by the theorem we can say two divides a square, then two divides a. Fine. So here, now when we know that 2 divides a, I'll write a as a is equal to 2c. Okay. So I'll just write one. Let us assume a is equal to 2c. When I write it like that, I'll also write that substituting it, then 2b square is equal to 2c to the whole square, where 2b square is equal to 4c square, and 2 are common in both the sides. Cancelling it, b square is equal to 2c square. Then I'll write again by using the theorem. We can say that 2 divides b square, then 2 divides B. Correct? Okay. Here you can see that 2 divides A and 2 divides B also. So we can just conclude, therefore, A and B have at least 2 as their common factor. Correct? So this contradicts this contradiction has arisen due to incorrect assumption. Hence, therefore, root 2 is an irrational number. Fine. Here, why did this contradiction has shown that it is an incorrect assumption? Because in the starting, we had written here that A and B are co-prime numbers, and I explained you that co-prime numbers are those numbers which cannot be simplified further or which just have 1 as a common factor. So here we saw in the question that we were getting 2 as the common factor for both number A and B. Therefore, A comma B have at least 2 as the common factor. We saw they both were getting number 2 as the common factor. So we have just written below that this contradiction has arisen due to incorrect assumption. Therefore, root 2 is a irrational number. I hope you understood the concept. I know it is a bit difficult or maybe a bit confusing while writing, but you must write in the same way to get marks. There's no other option. You must mug up, but it's all fine. You can do it. Okay? That's it, students. I'm ending this lecture with the real number topic where I have covered the whole chapter. You would soon be getting one more lecture regarding the exercise in the real number topic. Okay, if you have any doubt, please write down in the comment so that I can solve it during your exercise video. Fine. Thank you so much for listening me, watching me, and I hope you understood the topic very well. All the best.